we're going to look at factoring. And just a reminder, the difference between factors and terms. Terms are separated by addition or subtraction. So 2 plus x, 2 and x would be terms, whereas 2 times x, 2 and x would be factors. One way to think of factoring is multiplying. Since 6 is 2 times 3, 2 and 3 are called factors of 6, and 2 times 3 is the factored form of 6. To turn these into, look at polynomials, the factored form of 6x squared y is 2 times 3, x times y. And the factored form of 9x squared y cubed would be 3 times 3 for the 9, x times x for the x squared, and y times y for the y cubed. Notice looking at these two monomials, they have some common factors. They both have a 3, x times x, and they both have a y. And so we say 3 times x times y is the greatest common factor, 3x squared y. To factor out a greatest common factor from a polynomial, which we usually abbreviate GCF, we determine the greatest common factor of the polynomial's terms and undistribute, factor out the greatest common factor. Our goal is to have an expression that's equivalent to the original polynomial, but that expression that's a product of a monomial and a simpler polynomial. So something times something rather than something plus something. So if we take the 6x squared y, we can factor that again. 2 times 3 times x times y, plus 9x squared is 3 times x times y times y times y. And again, 3 is common to both of these terms. The xx is common to both of these terms, and both of these have at least one y. So we can factor out the 3x squared y, and then we'll have this times the remaining factors. So from the first term, everything was factored out except for the 2, and then we'll still need the addition sign to separate the two terms, and then what's left from the second term is the 3, and then a pair of y's, so y squared. And what we've done is undistributed out the common factors. If we were to take this and multiply it back together, taking the 3x squared y times 2 would give us 6x squared y. Taking the 3x squared y times the 3y squared would give us the 9x squared y cubed. So we factored this into something times something else. That's factoring. A few more examples. Now this first one, 8y squared plus 4, sometimes you can spot these quickly, sometimes you'll want to go ahead and expand it out. This one I think you can kind of see that with the 8 and the 4, what's common to both of these terms is a 4. We can't, a y squared is not common because the second term, the 4, has no variable, so no y. So what we can do is undistribute out the 4. And one way to think about this is 4 times what would give us what we started with. So 4 times 2 would give us the 8, and then the y squared. 4 times 2y squared is 8y squared. And then we'll need our addition sign. And then 4 times what is 4? Well, 4 times 1 is 4. And this would be our factored form of the polynomial. 4 times the 2y squared plus 1. And our next example, the 24, the 6, and the 18, I think you can see that 6 is the greatest common factor for those coefficients. The only variables we have are x's in this particular polynomial. So we go with the x with the smallest exponent, x squared. Each of these has at least an x squared in it. We can break it down. 24 would be 6 times 4 times x squared. Subtract, we've got 6. X cubed is x squared times x. Plus 18 is 3 times 6. And then x squared times x squared. And then you can see we have the 6 common to all three terms, and an x squared common to all three terms. So if they factor out the 6x squared, that leaves behind the 4, subtract x, plus 3x squared. And again, we can check our work by distributing back. 6x squared times 4 is 24x squared. 6x squared times the subtract x would give us subtract 6x cubed. 6x squared times 3x squared would give us 18x to the fourth, which is what we started with. And so this is our factored form of the original trinomial, the original polynomial. You can try the next one, and I'll pause for a moment. All right, did we come up with the same result on the third example? The 20a to the fourth b squared, I broke down to 4 times 5. A to the fourth, I broke down to a squared times a squared, and then b squared. The 12 I broke down to 3 times 4, a squared, b squared. The 4 was common to both, the a squared was common to both, and the b squared was common to both. Undistributing out the 4a squared, b squared, left behind the 5a squared, subtract the 3. So for a final answer. And just a note here, on the first example, this one back here, that 1 is not optional. Without having the 1 as a placeholder, we would not have an equivalent expression. The second term of the polynomial would be lost. So get in the habit after you're done factoring out the greatest common factor is either physically writing out the check or at least mentally distributing back into the polynomial to be sure that you have everything that you started with and you have an equivalent expression to what you started with. Sometimes there can be more than one correct way to factor a polynomial. This would depend on whether or not we factor out a sign when we factor out a coefficient. So with the 2, the 4, the 6, we can see they're all even, so a 2 is common to every term, and everyone has at least one x. We can factor out either 2x. If we factor out a 2x, that would leave behind a negative x squared, as 2x times negative x squared is negative 2x cubed, plus another 2x, as 2x times 2x is 4x squared, subtract a 3, as 2x times the subtract 3 would give us the subtract 6x. But we also could have factored out, instead of a positive 2x, we could have factored out a negative 2x. And this would change the signs of our trinomial. A negative 2x times a positive x squared would give us a negative 2x cubed. And a negative 2x times the subtract 2x, and negative times a negative is a positive, 4x squared, and then we'd have a plus 3. So depending on what we're trying to do with the polynomial after we factored it, sometimes we may want to factor out a positive coefficient, sometimes we may want to factor out a negative coefficient.